Quarter 2 Learning Activity Sheet, Week number 7, Lesson 2. Introduction to Proof. What is proof? Proof is a sequence of true facts or statements placed in a logical order. Postulate is a statement that is accepted as true without proof. Theorem is a statement that must be proven before it is accepted as true. Properties of real numbers. Commutative property of addition. A plus B equals B plus A. Example, 10 plus 7 is equal to 7 plus 10. Commutative property of multiplication. AB equals BA. Example, 2 multiplied to 4 is equal to 4 multiplied to 2. Associative property of addition. A plus the quantity B plus C is equal to the quantity A plus B plus C. Example, 2 plus the quantity 7 plus 5 is equal to the quantity 2 plus 7 plus 5. Associative property of multiplication. A multiplied to the quantity BC is equal to the quantity AB times C. Example, 4 multiplied to the product of 2, 3 is equal to the quantity 4, 2 multiplied to 3. Distributive property. A distribute to B by multiplication and A is distributed to C by multiplication. So we have AB plus AC. This is their distributive property over addition, or distributive property of multiplication over addition. Example, 2 multiplied to 4 is 8 and 2 multiplied to 5 is 10 and 8 plus 10. Properties of equality. Properties of equality for all real numbers A, B, C, and D are the following true. First, reflexive property. A is equal to A. Like 7 equals 7. Symmetric property of equality. If A is equal to B, then B equals to A. Transitive property of equality. If A equals B and B equals C, then A equals C. Addition property of equality. If A equals B and C equals D, then A plus C equals B plus D. Subtraction property of equality. If A equals B and C equals D, then A minus C is equal to B minus D. Multiplication property of equality. If A equals B and C equals D, then AC is equal to BD. Division property of equality. If A equals B and C is not equal to 0, then A over C is equal to B over C. Substitution property. If A equals B, then A and B may be substituted for each other in any equation or inequality. Zero product property. If AB equals 0, then A is equal to 0 or B is equal to 0. In other words, both A and B are equal to 0. Now, properties of congruence. Reflexive property of congruence. Segment AB is congruent to segment AB. Symmetric property of congruence. If segment AB is congruent to segment CD, then segment CD is congruent to segment AB. Transitive property of congruence. If segment AB is congruent to segment CD and segment CD is congruent to segment EF, then segment AB is congruent to segment EF. Examples: state the property of equality or congruence that justifies the conclusion. Given segment AM is congruent to segment MN and segment MN is congruent to segment NP, the conclusion will be segment AM is congruent to segment NP by transitive property of congruence. Second example, given 9x is equal to 45 and the conclusion is x is equal to 5 by division property of equality. Third example, given measure of angle 1 is equal to the measure of angle 2 and the measure of angle 1 is 79 degrees, conclusion, measure of angle 2 is equal to 79 degrees by substitution property of equality. Fourth example, given x minus 4 is equal to 11 and the conclusion is x equals 15 by addition property of equality. Fifth example, given segment PQ is a segment, conclusion, segment PQ is congruent to segment PQ. The property is reflexive property of congruence. Now, use the given property to draw a conclusion. Number 1, using symmetric property, the given is AB equals CD. Therefore, the conclusion will be CD equals AB. Number 2, transitive property. Using transitive property, the given are EF equals GH and GH equals IJ. The conclusion will be EF equals IJ. Third, using reflexive property, the given is KL is a real number. The conclusion will be KL equals to KL. Fourth, using transitive property of equality, the given are measure of angle 1 is equal to the measure of angle 2 and the measure of angle 2 is equal to the measure of angle 3. The conclusion will be the measure of angle 1 is equal to the measure of angle 3. Now it's your turn. Using the addition property, the given is 5x minus 7 equals 23. What will be the conclusion? The conclusion will be 5x equals 30. Next, using associative property, the given is the quantity m plus n plus q. So we have m plus the quantity n plus q. Next, using commutative property, the given is d plus f. Therefore, the conclusion will be f plus d. Distributive property, so the given is 7 multiplied to the quantity x minus 4. It will be, the conclusion will be 7x minus 28. Now, let's proceed on writing a proof. In writing a proof, we can use a two-column proof consisting of the statements and its reasons. For the first example, we need to prove x is equal to 3 from the given 5x plus 4 equals 25 minus 2x. First statement will be 5x plus 4 equals 25 minus 2x. And the reason for the first statement is given. Take note that when we are writing a proof, it must be in a logical manner. The second statement will be based on the first statement. Since the first statement is 5x plus 4 is equal to 25 minus 2x, which is the given, the second statement will be 7x plus 4 equals 25. And the reason for this is actually addition property of equality. For the third statement, it is actually based on statement number 2. So the third statement will be 7x equals 21. And the reason for the third statement is subtraction property of equality. And lastly, for number 4 or for the fourth statement, based on the third statement, we will conclude that x is equal to 3, and that is supposed to be the division property of equality. So that's how to prove a certain algebraic expressions. But take note always that in writing a proof, it must be coherent to the other statements. There are some reasons to be used aside from the different properties of equalities or congruence. We can also use definitions, postulates, and different kinds of theorems in giving some reasons in writing proof. Let's proceed to the next example. Now, we will gonna prove a certain theorem, and the theorem is vertical angles are congruent. So we can write the statement into an if-then so that we can easily understand what we are proving for. So if two angles are vertical, then they are congruent. The given is angle 1 and angle 3 are vertical angles. So look at the picture. We have two lines there which are vertical, and we need to prove that angle 1 and angle 3 are congruent. So first thing to do, our first statement is actually we need to start with the given. Always start your proving with a given. So from the first statement to conclude the second statement, which is actually angle 1 and angle 3 are vertical angles, probably the second statement will be angle 1 and angle 2 form a linear pair, as you see on the picture. And angle 3 and angle 2 can also form a linear pair. Therefore, for the reason of statement number 2, it must be the definition of linear pair. For the third statement, based from the statement number 2, we conclude that angle 1 and angle 2 are supplementary, same as angle 3 and angle 2 are supplementary. So for that, the reason will be if two angles form a linear pair, then they are supplementary. This is actually a theorem. And from statement number 3, we can conclude for the statement number 4 that the measure of angle 1 plus the measure of angle 2 is equal to 180. And measure of angle 3 plus the measure of angle 2 is equal to 180. The reason is this is the definition of supplementary angles. As you observe, each statement is based on the previous statement, so it must be logical manner, coherent. The statements must be in coherent manner. Now, for the fifth statement, since the fourth statement indicates that the two angles are supplementary with a total of 180 degrees, we can conclude that the measure of angle 1 plus the measure of angle 2 is equal actually to the measure of angle 3 plus the measure of angle 2. The reason here is substitution property. It is based on the statement number 4. For statement number 6, we have measure of angle 2 is equal to the measure of angle 2. The reason here is reflexive property of equality. And from this, we can conclude for 7 that the measure of angle 1 is equal to the measure of angle 3 by subtraction property. So we used statement number 5 and statement number 6 to conclude statement number 7. And lastly, for the 8th statement, we conclude that angle 1 is congruent to angle 3 by definition of congruent angles. We already now prove that vertical angles are congruent and angle 1 is congruent to angle 3.